All right, our lesson is solving basic trig equations. We're gonna build on this skill as we move along, but here's the basics of what's happening. The goal is to find the angle or angles for the given ratio of sides, or state no solution. So some examples here. We have to find all the solutions. This is a key word for finding all solutions. The next problem also says to find all solutions. The next problem does not say to find all solutions, but instead to find the solutions from this interval, 0 to 2 pi, which, as we know, 0 to 2 pi is like 0 to 360, or 1 time around the circle. So what we are solving here is for x. Normally what we've been doing is finding the ratio. So this is the ratio of sides. This would be the opposite to the hypotenuse. But x, what we're solving for, is the angle. That's what we need to solve for x. So the angle's our answer. Well, when we do angles, we either can have angles in radians or degrees. And so you don't have a choice of how you want to present the answer. Like if you don't have a choice if you use radians or degrees. What you have to look for is if they have a little symbol of the degree bubble here, then they want the angles in degrees. Or it might be typed and it might say in degrees. But if you don't see that little bubble, then that means you're in radian mode. So look for that little degree bubble. That's degrees. Otherwise, we're in radian mode. All right, so what we can do is look at our unit circles, our fastest way to find these problems' answers. So we have to look at sine. Sine is the y coordinates of the unit circle. So we're looking at y coordinates to be negative rad 3 over 2. So I see, looking around the y coordinates, negative sine should be in this quadrant and this quadrant. So I've got the y coordinate here. So the answer here I've got is 4 pi over 3 is my angle for the y coordinate is sine. Now here's the deal though. It says to find all solutions. So what they mean by that is like if I'm on this circle and I got to 4 pi over 3, technically I could move around the circle another 2 pi and add 2 pi to whatever that angle is, and I would still have the same exact location on the circle. I could add another 2 pi and get back to here, and I'd still have the same exact answer. So I could keep adding 2 pi plus 2 pi as many times as I want, and that would be all solutions. So to describe the all solutions here, I would write plus 2 pi to get the next answer, just spinning around again. But then I could keep doing that forever, so I'm going to put 2 pi n, and n represents an integer. So for however many times I want to spin around the circle, n could be infinite times around. But that's the answer where we start with, and then I could just go around again and again. So anytime it says all solutions, we're going to put the plus 2 pi n. That's one angle, actually. If you notice, there is this quadrant as well. Sine would be a negative, and so this angle right here, the y coordinate, is negative rad 3 over 2. So 5 pi over 3 is a second answer, and you need to put that answer as well. And like the last one, it could go around the circle an infinite amount of times, so you have to put plus 2 pi n to represent all infinite solutions. Some books might use 2 pi k, and that doesn't matter. You can use whatever integer or variable you want. One thing to note is when it is a sine or a cosine problem, you're going to put plus 2 pi n because that's the period of sine and cosine, or just around the circle. But tan is an interesting case. Tan, you would only put 1 pi n because the period for tan is 1 pi. Let me see if I can show you on the unit circle like how tan is only 1 pi. For example, let's just say I picked this tan value right here. Notice that if I'm at this, I could move around 2 pi and get to the same spot. Of course, I could do that every time, could keep adding 2 pi. But this line with this answer right here, actually, if you follow straight across the diameter, has the same exact value. Only tan does that. And what that means is, if I want to go from this point to this point, since it was along the diameter, a perfect straight line across, it's moving 1 pi, or 180 degrees, half the circle, 1 pi. So what that means is if I want this answer for tan, I can just find this one and put plus pi n, and if I add pi, I get to here, the same answer. And if I add pi again, I get back to here, and add pi again, and add pi again, add pi again, and I keep hitting these 2 points every time. So for tan problems, just put plus pi n. All right, let me just finish up these problems here. For cosine x equaling 1, we can see from the unit circle, cosine is the x coordinates equaling 1 would be here, and no, so just here. So the answer is x equals 0 radians, but I can continue and get to this point by just adding 2 pi over to get to it again. To get to it again, I add another 2 pi and another 2 pi. So it's just 0 plus 2 pi n. Well, I don't need to put 0 plus. I can just write 2 pi n, and that would represent the same thing. So every 2, but basically this is saying you'll hit a value of 1 every 2 pi that you move from 0. Now, the last one says to find the solutions for cosine at rad 2 over 2. So cosine positive would be either in the first quadrant or in the fourth quadrant. And we look at the x coordinates. So here's 1 and here's 1. There's 2 answers here. So x equals pi over 4. Now, because the interval only wants us between 0 to 2 pi, that means only 1 time around the circle. So I don't want to put plus 2 pi n, not for this problem. I don't want all infinite solutions. So only the solutions that are shown on the unit circle when it gives us this interval. And then the other one from down here was 7 pi over 4. So that's the answer then. No plus 2 pi n, unless it said to find all solutions.